to today's lesson. So today we're going to be solving 2D shapes with trigonometry. Remember, we've looked at a few concepts that had to do with the introductory of 2D shapes, which was triangles, and that was right-angled triangles. We then looked at also some special angles, equations, and expressions. Now we're gonna jump into more 2D shapes and see exactly how do we then solve these things. Maybe if I'm standing here and I'm looking up and I want to see maybe what's happening up there, there's what we call an angle of elevation, which are things that we're going to be talking about. If I'm looking down maybe at an object that's below me, there's an angle of depression that I'm going to be talking about. So those are the things that we're going to be looking at in this particular lesson. So stay tuned and learn some more with the mathematics guy. So let's look at this. Remember that I want to always ask you a question for you to be able to think about this as we are starting the lesson. Have you ever thought about how to find an unknown side when given two sides? This must be two sides. And also to find an unknown side when given a side and an angle. And remember, with our previous lesson, we kind of answered the first question. When given two sides, we can use the Theorem of Pythagoras. And also we kind of introduced a bit on how to answer the second one that had to do with using ratios. Also, how to find an angle given two sides. Because remember, the big question that we had in our previous lesson was, what is the relationship between sides and angles of a shape? So that's what we are looking at as well. Now, our concept map, which is always what we start with, we're going to look at the Theorem of Pythagoras, definitions, our angles, 2D triangles, and then the Cartesian plane, which is the big idea. Now, for now, let's just do a quick recap of the Theorem of Pythagoras. Remember that this is only applicable to right-angled triangles, not any other triangle. Also, it describes the relationship between the three sides of a right-angled triangle. Remember, the longest side being the hypotenuse and the other two sides named according to their relation to the angle that is given. Also, we use it to find an unknown side when given two other sides. So already, we are answering the very first question that we just asked now. Can I find an unknown side if I'm given two other sides? Yes. Using what? The Theorem of Pythagoras. Now, remember that the equation of the Theorem of Pythagoras always starts with the longest side. Squared is equals to the sum of the other squares, right? Which will look something like this. It's c squared, which is my longest side, is equals to a squared, which is this, plus b squared, which is the other side. Also, one thing that I would like to mention here is remember that the a, the b, and the c, the small letters, they come from labeling the sides based on the opposite vertex to that particular side. So just quickly remember that as well. Now, if we look at, we are trying to find c, we will need to find the square root of what is on the right-hand side. If maybe I'm now given b and c and I'm trying to find a, I will then need to, so this will actually not be b and c, but a and c, and I'm trying to find b. I will then use the Theorem of Pythagoras, but now this is where the minus factors in. So you see, here I'm trying to show you where the minus comes into picture here. And remember, we want to find b on its own. I must take out a square root on both sides. Now, that's the big idea of what we've looked at, right? So now we're going to look at ratios. And in terms of ratios, remember that I said ratios are about defining them. And please remember, guys, when I say to you, you need to give me a definition of a trig ratio. I'm not saying now you must go all Oxford dictionary for me or your Google and be telling me that sine is this and sine is that. No, I'm just saying give me what is the definition in terms of the ratio of sine. meaning according to the OHEL, another hour of algebra, or SOHCAHTOA that we spoke about in our previous lesson. That's where the definition is. So the definition here is a mathematical definition and not just a normal English definition that we normally give. So please note that. Now, we're going to look at the ratios and also our angles. Consider the right-angled triangle ABC with angle theta. Remember that AB will be the hypotenuse side, and then I will have the adjacent side to theta. I will have the opposite side to theta. Remember we said we label the other two sides in relation to the angle that we are given at the time. And now also, if you look at this, we can try and find the ratios, which is our sine ratio. That's the opposite over hypotenuse. Remember I said at times we can write OPP and hype instead of the whole word. Because remember, we are very smart people as mathematicians, so we normally shorten these things for our advantage. Also, the cos ratio, we can always write it as add with the J or adjacent over the hype as well to mean hypotenuse side, and then the last ratio will then be the tan theta, which is equals to opposite over adjacent. And remember we also have the reciprocal trig ratios, which are normally linked to their original trig ratios that we have, the three ones, right? Sine correlates with the cosec, and cos correlates with the secant, and tan correlates with the cot or the cotangent ratio. Now, if we move on and look at the concept of the 2D triangles, remember that with our 2D triangles, we normally use these to find an unknown. Now we are trying to answer the second question that I asked you, to say, can I then find a side given one side and an angle, right? And you can see here I am given this side here, which is my hypotenuse side, and I'm given this angle here. And in relation to that angle, we know that FU will be the opposite. In relation to that angle, UN will be the adjacent. The question wants us to find the length of UF, right? Rounded to one decimal place. So UF will then be the opposite side. So remember, I have the hype, I have the opposite, or I'm looking for the opposite, I have the angle, then my ratio will be the sine ratio. So to solve this, I will then use the sine ratio because of everything that I have. So this will be sine 28 degrees, which is equals to the UF, which is opposite, remember that, over 10, which is the hype. And then I'm trying to find the UF. I will just do the basic algebra, which has to do with cross multiplication or multiplying both sides by 10. So this will be 10 multiplied by sine of 28 degrees, and then we go straight to our calculator to then solve this. So it will be 10 multiplied by sine 28. Remember, when you are using your calculator, you need to make sure that it is in degrees, number one, and number two, it must be a scientific calculator and not the one we normally use to try and maybe add up some basic numbers at early grades of our mathematics. So they said rounded off to one decimal place, so this will be 4.7 units. You're not going to say centimeters, meters, or anything like that, because they didn't give us the 10 in terms of having specific units. Another question is, calculate the size of theta. Remember, the last question we had when I started was, can I then find an angle if I am given two sides, right? Now I'm trying to find the angle theta. In relation to angle theta, the 10 there will be the adjacent side. and then you know the 16 will just be the hypotenuse side. So now I'm having adjacent and hypotenuse, meaning I'm dealing with the cos ratio. So this will be cos of theta is equals to, my adjacent is 10 divided by 16. You don't necessarily need to write down the definition or the ratio from scratch to say adjacent over hype. You don't really need to do that if I've given you a triangle. You just need to substitute straight away and then start calculating. And then remember the steps I gave you in our previous lesson. You're going to press either second function or shift with the cos, and this will give you cos to the -1 into 10 over 16, and then you will then find what that angle is. So let's do this and see what do we mean. Shift cos, this will be 10 divided by 16, as I said, and therefore that will be 51.3. So it's just going to be 3 because it's to 1 decimal place. So this will be 51.3 degrees. Remember, theta is an angle, so we need to include the degree when we talk about theta. Now, we have what we call an angle of elevation, right? Remember when I spoke about where do we use these trigonometry, rather, in which fields? This was one of the images that we had when we spoke about people that are at sea and they're in a boat. They're trying to look at whether they will make it on time or they will make it when it's still daytime, or it will be nighttime by the time they get to a certain point. So this, we call it the angle of elevation. Now, if I explain what this is, remember that at times you look at, maybe you want to look at the stars, right? And as you're looking at the stars, the angle that your eye is making, or rather the line of the ray that you're looking at the stars with, and it is making with the horizontal surface, it is called the angle of elevation. If maybe you are at sea level or in a swimming pool and you look down inside the swimming pool, there's a coin maybe there and you want to jump in and take it out, you will then be looking at it from a point of the angle of depression, which is the angle that we normally look at when looking down. So that's what you will need to know about angle of elevation. So when you see an object above you looking from N, that's an angle of elevation. So here, the angle of elevation here will be 28 degrees. And the angle of depression, when you see the object below you, when you're looking from F here. And the reason why this is also the same as 28 degrees, because remember, these will be parallel lines, therefore it will make a Z shape, which we normally call alternate angles. I hope you're still okay with in terms of your lines there. Therefore, the angle of depression here will also be the 28 degrees. So the question that we need to look at here is the Cape Town table car, it takes tourists to the top of the Table Mountain, right? What we will want to know is if the distance from the top station to the top station is, or from the bottom station, I mean, to the top station is 1.2 kilometers. We want to find the angle that the cable makes with the horizontal at the bottom station, which is 40 degrees, you can see from that. Then the big question will be calculate the height, right? The height being from the Table Mountain up there to the horizontal surface, what will then be the height? So you can see here that I have that the angle there making H to be the opposite side and making this to be the hypotenuse side. So you can solve this using the sine ratio, right? So I'm sure that you can then do that. So let's maybe quickly look at it. So this will be sine of 40 degrees is equals to my H, which is what I'm trying to find, over 1, 2. And then you know. From straight with a calculator, you just press sine 40 multiplied by 1,2, and that will give me the height, which is 0,77, right? So h will be 0,77 kilometers. When you are not told how to round off your answer, remember to always round it off to 2 decimal places. So far, guys, we've looked at the angle of elevation, the angle of depression. We've also looked at how to try and find sides on a triangle if we are given 2 sides using the theorem of Pythagoras. Remember, where we include the plus is when we're looking for the longest side. When we're looking for the other 2 sides, we then include a minus, and that's what we're going to look at. So just stay tuned. We'll go to a quick ad break, and I'll be back with some more. Hi guys, welcome back. So we are still busy with solving 2D triangles with trigonometry. So we've looked at a range of things in our first segment, and we're just gonna go through a quick revision and try and look at different scenarios of what these conditions that we're talking about differ in terms of their differences and how we can solve it when it's like this and when it's like that. I know I'm saying a lot of like this and like that, but you will see exactly what I mean when I say like this and like that. So far, we've looked at the concept of Theorem of Pythagoras, which was the big thing, or which is still the big thing under your trigonometry at this level. And we then went on to look at some angles. Before that, we looked at ratios, and then we related them to angles. Remember our big questions. Can I then find an unknown side if I'm given 2 sides? Our answer was yes. Why? Because I will then use the theorem of Pythagoras. The second question I asked you is, can I find an unknown side if I'm given 1 side and an angle? And the answer also is yes, we saw that. If I'm given what? 1 angle and the side, I will use a ratio. Then the third question was, can I then find an angle if I am given 2 sides? And also, even there we said yes, because we will use what? Ratio. So that's what we are going to try and now investigate in this particular segment. Then later on, we'll look at the Cartesian plane and how all of this will then go to that cross of ours, which is a Cartesian plane that we use in mathematics. But for now, let's just do a quick recap of everything that we've done thus far. So remember that we're still looking at the theorem of Pythagoras, which I said was the most important thing when it comes to your trigonometry at this point in time. So you definitely need to know it. Also, we looked at the concept of definitions, and with definitions, we spoke about the concept of ratios, which was what I said. You don't define a ratio based on your dictionary definition or anything like that. No, you define it using opposite, adjacent, and hypotenuse side. And then we spoke about angles. Remember that our angles are normally your acute angles and your 90-degree angle in a triangle that we are dealing with at this present moment. Then we also looked at 2D triangles. The last concept that we're going to look at will be the Cartesian plane, but at a later stage. For now, that's the ratio. All right, so let's look at the 2 types of angles that we have. The first one is the angle of elevation. This is when you see an object above you, but looking from point N. So remember the example I made about looking at the stars or looking maybe at an airplane that you are seeing there in the sky. That's what we are talking about when we talk about the angle of elevation. And this angle here will then be the 28 degrees there. The second angle will be the angle of depression, which is when you see an object now below you, looking from F. So remember this, the example I made was when we're talking about a swimming pool and you're looking at maybe a coin inside there, or you're seeing something in the pool and you want to jump in to go and fetch it. The angle that you are seeing it at, we call it the angle of depression. Now remember that these sides are parallel to one another, making the two angles to be alternate. Hence, the angle of depression will also be 28 degrees. Now, we looked at the 2D triangles. And with 2D triangles, I said to you, when you are given something, there is something that you need to use, right? This is where I talk about that, this and that I was trying to mention when I was introducing this. So here, I am given the hypotenuse side. If I want to find maybe, let's say, the side UN, I am given the hype, which I will write HYP. I am given angle N, and I'm trying to find UN. Right, I'm trying to find UN. I will then need to use the cos ratio here, right? Why cos ratio? Because the UN will form the adjacent to the angle 28 degrees, and then 10 is normally the hypotenuse side. And that's how I will then do this. So let's try and solve that. If I am trying to find UN, remember in our previous segment, we actually found UF. Now we're trying to find UN. So this will be cos of 28 degrees, which will then be equals to my UN, which is normally the adjacent, over 10, which is the hypotenuse side. And then UN will therefore be equals to 10 multiplied by cos of 28 degrees. And then you will press this on your calculator, and it will therefore give you 10 multiplied by cos of 28. This will be equals to 8,82 or 83 if you round it off. So this will be 8,83, and that will be the length of UN. Now, if maybe I am now given the UN itself and I'm trying to find what FN is, I will then say I am given the adjacent to the angle, and I'm also given the angle. Now I'm trying to find Fn, right? And Fn, remember that this is our hypotenuse side. So to do that, we will then also use the cos ratio. And if you want to use the cos ratio here, this will still be cos of 28 degrees is equals to adjacent, which is 8, over the Fn, which is what I'm trying to find, and then you go to your calculator. Guys, please, you don't necessarily need to be straining yourself and trying to do mental math when it comes to trigonometry. I promise you, there will be questions that will say without the use of a calculator. But when they did not specify that, and you're seeing angles that are not special angles, you just go straight to the calculator. So this will be Fn is equals to 8 over cos of 28 degrees. And from my calculator, I will say 8 divided by cos 28, close the bracket, and that will give me 9,06. So this will be 9.06, and that will then be the length there. Then the last one also is, if now I'm given this side and I'm trying to find maybe UN, right? I will then use the tan ratio. If I'm trying to find the Fn, I will use the sine ratio. With this one, I will use the tan ratio. So let's look at what exactly does that mean. If I'm trying to find, let's start with UN first, right? UN, remember we said it's going to be tan. So this is going to be tan 28 degrees is equals to the opposite, which is 6 over UN, which is what I'm trying to find. And then you use your calculator from there. So UN will be equals to 6 over tan 28 degrees. and I will go straight to my calculator. This is 6 divided by tan of 28, and that will give me 11.28. So this will be 11.28. And then if I want to find now Fn, which is the longest side, I will then use sine. Why? Because I'm given the opposite side in relation to the angle, and I'm trying to find the longest side of this triangle. So this will then be sine 28. Okay, let me just erase that and write it properly. So it will be sine 28 degrees is equals to my FU, which is 6 over, I'm trying to find Fn. And then from the calculator perspective, you know this is then going to be 6 divided by sine of 28, and then it gives me 12.78. So Fn will then be 12.78. Right, so you can see that this is just when we are trying to look at different perspectives of how to then use your ratios. You always need to look at what are you given, and then which ratio can I use from what I am given. And then if we are trying to then solve for an unknown angle, remember you always look at the sides in relation to the angle. This is adjacent and this is hypotenuse. So it means I'm going to therefore use cos, right? And I'm given the adjacent and also the hypotenuse side. And then if maybe I'm given now the opposite side to theta, so here I'm given the opposite and also my hype, I will therefore use the sine theta ratio, right? So this is just me trying to show you, when given this, what do you use, so that you know exactly how to then maneuver your way around trying to solve these things. And then the third one will then be, if I'm now given the opposite and the adjacent. You know for a fact opposite and adjacent has to do with the tan theta. And therefore, you can then solve these things from that perspective. So make sure that you know exactly what is it that you are given so that you are able to solve for the ratios. We're still looking at solving 2D triangles with trigonometry. That's the main thing that we're trying to do. So now we're going to try and link this to a Cartesian plane and see exactly what does it mean on a Cartesian plane when maybe you're trying to find an angle or trying to find a side, and what letters do we use to do that. But we're going to do that just after the quick ad break. Stay tuned. Hi guys, welcome back. So we are still busy with solving 2D triangles with trigonometry. Now, remember I said before we went to the ad break, we're now going to look at the Cartesian plane, which is actually one thing that we all really know from an early stage of doing our mathematics. We've been doing graphs, but now we're going to look at a Cartesian plane in the context of trigonometry and try to see what are the ratios and how do we find the ratios based on the Cartesian plane and all of that. So far, what we've looked at is the Theorem of Pythagoras, which we did in great length. We looked at the concept of the two types of angles. We just looked at the concept of 2D triangles. Now we're going to look at the Cartesian plane, and in the Cartesian plane, we will then try to find the ratios based on the Cartesian plane, or using the Cartesian plane as the frame of reference, and also some special angles there. Now, what is a Cartesian plane, right? A Cartesian plane is normally something that looks like a cross, but with arrows at the end of every line, right, that we are having. It normally has negative values, it normally has positive values, and also positive values, and negative values. But really, let's talk about what this is. This was designed by a French mathematician, which was René, right? René said this particular thing, which is a Cartesian plane, it defines the position of points in 2D space, right? In reference to the two perpendicular lines, which we normally call our axes, right? So, as you saw that there will be two lines that are crossing each other. Where they're crossing each other, it is normally a perpendicular to one another where they are crossing. And this point where they are crossing, we normally call it the origin, which is where everything starts on the Cartesian plane. So you don't start on the right-hand side of the Cartesian plane or at the bottom there. No, you start from the origin. You either go up, go right, go left, or go down. But you always starting from the origin there, which is that point where the axes are intersecting. So the origin will be the blue dot there that I'm showing you there. So that's where the origin is going to be. Now, I spoke about the axes as well. We have what we call the horizontal ones and the vertical ones, because really it's something like this. So this is vertical and that is horizontal. The horizontal ones, we call them the x-axis, and the vertical ones, we then call them the y-axis. So this is how we really define it. Now, you will see most of the time when they draw or when we draw Cartesian planes, we normally write a very small y there and a small x there. That's to label the axis according to x-axis and y-axis. So that's why we have them there. But you don't necessarily need to have x, y everywhere. So you don't need to have another y down there and another x on the left-hand side there. No, just one label there and one label there does the trick. Remember also our origin is still there by the center. Now, every point can be described as an ordered pair, right? When I talk about an ordered pair, remember we're talking about x and y, right? And I know most of you guys will then be saying x comma y. Please, it's x and y, because remember the semicolon in language terms, it means and. So if I say make a list of something, you will be saying red, semicolon, blue, semicolon, yellow. The semicolon means red and blue and yellow and green continuously. So please don't then call this a comma. Remember that maths is a language on its own, so you need to speak it properly. So the point of intersection of this axis, remember we said, is called the origin, which is where everything starts. Excuse me. The origin is the point O. We normally label it with just O, O for origin. And the coordinates are normally 0 and 0. Now, I've seen people draw their Cartesian planes, and on the Cartesian plane, they start now having on the origin 1, or they're having 3. That will never be the case, because if you're saying this is the origin, it must always be 0 and 0, because that's where the numbers start from 0, either going to the positive x values or the negative x values, going to the positive y values or going to the negative y values. So you need to make sure that your coordinate of the origin is always 0 and 0. So that's what the origin is all about. Now, if we look at a Cartesian plane and I want to plot this as it is 0, so the first 0 is for the x-axis, right? Because that's where the number line starts. Because remember, if I draw a number line, by the middle there, that's where my 0 is, right? And the second 0 will be for the y-axis. The y-axis as well, if I draw a number line vertically, there by the center, it's also 0. Hence, it's 0 and 0. But this O is not really 0 as a number, but it's O as a letter, which means origin. So please note that. Now let's try and look at how do we divide this Cartesian plane? We divide this Cartesian plane into what we call quadrants. And the quadrants on a Cartesian plane are 4. As you know that there's like 4 sides, if we were to call them sides. But mathematically, we call them quadrants, right? And they normally labeled using the Roman numerals. So quadrant 1 will look like that. You're not really going to write 1 as a normal number, but you write it as a Roman numeral. And then quadrant 2 with a Roman numeral, quadrant 3, and quadrant 4. But let's look at this on a Cartesian plane itself. This is how it will look like. So this will be quadrant 1, that will be quadrant 2, quadrant 3, and quadrant 4. Now, if we are trying to find angles, right, and trying to now link the ratios to this particular Cartesian plane, we're going to try and say, let's let R be a line of a fixed length, right? And R would then be the radius in this instance, because we're going to try and draw a circle around there. One end of R is fixed at the origin, so it starts from the origin, meaning the line R starts from the point of intersection of the axis, and then it moves around the origin in an anti-clockwise direction. For us to measure angles on a Cartesian plane, we start from the x-axis on the right-hand side, and we move in an anti-clockwise direction. Then the angle of rotation theta is normally measured between the x-axis and R, as I just said now. So let's look at this. I'm using 8 and 6 because it makes it to be a right-angled triangle if I was to conclude it drawing the line like that. So for me to measure the angle theta, it is between, let me just try to use a different color here. It is between the point of origin here, which is this horizontal line of the x-axis, and this line that I have here. And this angle here will then be the angle theta, right? So that's what we are talking about when you're talking about the angle theta. The angle of rotation may be greater than 0 degrees but less than 90, or equal to 90 degrees, right? Then the point P at the end of R will then be in quadrant 1. And what do I mean by that? I mean that P will be placed in quadrant 1. Why? Because theta is between 90 degrees, which is less than 90, but greater than 0 degrees. Why 0 degrees? Is because at this point here on the positive x-axis, we normally start from 0 degrees going in an anti-clockwise direction. Also, this angle might be greater than the 90 degrees, but less than or equal to the 180 degrees. Therefore, the point P will be placed in quadrant 2. And in quadrant 2, it means that at this point here, that's 90 degrees, because this makes a right angle there, and this will be my 180 degrees there, and this will then be my 270 degrees. This is 0, and also my 360 degrees. So between 90 and 180, it will then be in quadrant 2. Remember, I will keep on emphasizing, we start on the positive x-axis and we move in an anti-clockwise direction when you're trying to measure angles. But now look at also the value or the values of P. The 8 will be a negative. Why? Because we're on the negative side of the x-axis, but the 6 will remain a positive because we're still above the x-axis. Now, if this angle is now greater than 180 but less than 270, the point P will be placed in quadrant number 3. In quadrant number 3, this is how it will look like. Remember, we start from here and we move in an anti-clockwise direction like that. So the angle theta will be from this line here, which is the horizontal axis, going to the line R, and that will be the angle that is greater than 180, which is normally here, but less than my 270 degrees. I know that we normally call this your reflex angle. And then if now our angle is greater than 270 but less than 360, this point will then be placed in quadrant number 4. And in quadrant number 4, remember the x is positive, but the y is negative. Now, guys, with this that we've just spoken about here, I'm just trying to locate all these points for you to see in terms of if we were to then start solving, right, these ratios and talk about if a point or ratio sine theta is equals to -3/5, right? You know the -3 means that it's the y value that is negative. And where is the y value negative? Either in quadrant number 3 or in quadrant number 4, right? So you look at which one between the two quadrants will I locate the sine theta. That's what we are trying to do here. Hence, I've been using the point P going forward to try and talk about the angle theta being placed in different quadrants because of its magnitude at the time. Now, if we want to define these ratios, we define the ratios for any angle in the interval 0 and 360 degrees, as I showed you in terms of the Cartesian plane, and I was plotting my values. The angles are no longer limited to being acute angles, which are normally found in triangles, but they can now move from 0 up until they get to 360 degrees. And can you suggest a way of defining trig ratios on the Cartesian plane rather? Let's look at maybe quadrant 1. If you look at quadrant 1, you can see that if I want to find the angle theta, right, and I'm given the adjacent side and the opposite side, right, because remember that my 8 there will be the adjacent side, which is the x value, so it's the x length, and the 6 value there will be the vertical value, which is y. I will then look at the sine being the opposite over a hypotenuse, which is y over r. Why? Because the opposite is the same as y, and the adjacent is the same as x. And with this, if I want to find cos will then be adjacent over hypotenuse, which is x over r. And then lastly, the tan theta one will then be opposite over adjacent. Remember, my opposite is y, and my adjacent is x, therefore that's y over x. Now, let's try and put this into perspective with a specific question now. Given P, which is -8 and -6, which is a point on the Cartesian plane, and theta that is on the Cartesian plane, calculate the value of tan theta and calculate the value of sine theta divided by cos theta. Right? So let's start with the first one. If I am given that I want to find tan theta, remember that if I want to close my triangle, it will be me closing it in the third quadrant there, because that's where the -8 and the -6 is. Therefore, I am given this as -6, and I am given that as -8. So it means I have the opposite and the adjacent. So to find the theta there, I will then use the tan ratio. So this will be tan theta is equals to, remember we said it's y over x, which is equals to -6 over -8, and this is still my tan of theta, and then theta will be the second function of tan into 6 over 8. And then you can press your calculator there to try and find what the answer is there. And then if you want to find the value of sine theta, now divide by cos theta. Remember, sine theta is going to be y over r, and I'm dividing this by x over r, right? So my y, remember, it's minus 6 over, I don't know what the r is yet, divided by, but my x is negative 8 over r, which I don't know as yet. And then I can find r using the theorem of Pythagoras, right? But you can see with this particular one, I wouldn't really need to do that, because this will be negative 6 over r multiplied by r over negative 8, and the r will divide, and therefore this will be negative 6 over negative 8. Now, as I'm thinking about this, I saw something here. So here, the answer of tan theta will actually be negative 6 over 8, over negative 8, which is just 6 over 8. But if we were to find the actual theta, we will then use the second function. So you only use the second function if you are trying to find the theta. Now, the summary of everything we've done so far is we looked at the equation from the Theorem of Pythagoras. Remember that the longest side is what we normally start with, which is our hypotenuse side. And then if you try to solve for it, you find the square root both sides. We also looked at our 6 ratios. The first 3 are the generic one that we're going to carry on using with your mathematics career. But the reciprocals we are doing at this level, which are the opposites of the 3 generic ratios, it's normally 1 over the ratio, and you will then find the values there. Also, when you see an object above you looking from n, remember that we are talking about the angle of elevation, and if you're looking at it below you, we're talking about the angle of depression. And then lastly, for each point, we're now going to use x, y, and r to try and talk about the ratios. Sine theta is y over r. If I say to you, define sine theta, I want you to say y over r. Define cos theta, x over r. Define tan theta, y over x. And that's what we're then going to say as the definitions. Now, the big idea here, guys, has been trigonometry. We looked at the Theorem of Pythagoras. The reason why I've been including Theorem of Pythagoras is because it's such a big idea and it's such a big concept of your trigonometry, because most things that you're going to do, they involve the Theorem of Pythagoras, which we really, really need to know and master. And we also looked at our definitions in terms of x, r, and y, which we just did now. We looked at our Cartesian plane and the 2 types of angles that we spoke about, and 2D triangles. And that's all that we have to do for today's lesson. I will see you guys next time.